So we're going to start 8.3 tonight, and I want you to read through the pages 499 to 507 and to take some notes on the back. It's just a way to introduce it a little bit more quickly tomorrow, so if you would please read that tonight. And then also you're going to do a little activity on your calculator that I'm going to guide you through. So we have something called calculator bingo, and if we did this in the classroom, we would be yelling bingo if our interval did not capture the true population parameter. So tomorrow we'll discuss how often each of the methods did you actually capture the true population parameter. So a farmer wants to estimate the mean weight in grams of all tomatoes grown on his farm. To do so, he will select a random sample of 4 tomatoes, calculate the mean weight in grams, and use the sample mean to create a 99% confidence interval for the population mean. Suppose that the weights of tomatoes on his farm are approximately normally distributed with a mean of 100 grams and a standard deviation of 40 grams. So we're going to use the calculator to simulate taking an SRS, a size 4, so small sample, but that's okay because the population is approximately normal from the population and creating a 1 sample Z interval. So I'm going to walk you through this. But first I want to remind you that when you are doing this, you have a statistic plus and minus the critical value, and this is what is on the AP exam formula sheet, critical value, times the standard deviation of the statistic. So I want to write out the actual formula that this will translate into. So we are going to create a Z interval. We've never done one of these before. This is brand new. So we're going to take our statistic, and it's going to be a mean from the 1 sample that we get. But we're going to do this many times. And then we will add and subtract the critical value, which is our Z star. So we'll find this the same way we have in the past. And then we're also going to use our standard deviation, which is sigma, over the square root of n. So let's put some actual values in here. X bar, of course, every time will be different, every time we repeat this. Our critical value will be 2.576, and we worked on that yesterday, so if you're not getting that, we need to talk about that. But essentially, if it's a 99% confidence interval, that means in each of the tails you have 0.005. So you would just do inverse norm with that. And then, of course, the standard deviation will be 40 every time. And we'll divide by the square root of 4 every time, which, of course, is just 2. Now, the only thing that will change every time is going to be our X bar. So that is what we're varying from each time that we do this. Every time it's just going to change X bar. Everything else will be the same. All right, so we're going to do this in the calculator though, so it's going to be nice and easy for us. And I'm going to also work on using the test so that you can see that. I'll demonstrate that for you as well. So I'm going to go into the calculator, and the first thing I'm going to do is I want to create a sample of 4 that matches the population, or that is taken from the population that was described in this scenario. So we're sort of doing a simulation here. So what I'm going to first do is I'm going to go into math. I'm going to go over to random normal, which is option 6, and by all means pause if you need to. My mean is 100. That's the mean of the population, and I want a standard deviation, so sigma is 40. And I'm going to create 4 observations, or a sample with 4 observations. I'm going to store this, so that's the little button down there, in list 1. Now you may want to clear out list 1 before you start. I know mine has already been cleared out. And then I generate it. So I can see the first observation is 98.48. So when I go to list 1, I can see that 98.48 right there. So those are my 4 observations. Now we're going to repeat this many times, but before we actually do the next step or the next selection, we're going to construct an interval. So I'm going to go to Stat, I'm going to go over to Test, is going to be option 7, the z-interval. Remember we talked about this is not what you use for proportions when you're constructing a confidence interval. You would use the, I'll just show you just so you can see, compared to what we've done so far. So far we've done the one prop z-interval. Now we're doing option 7, which is just a flat out z-interval. Okay, so option 7, and I'm going to use statistics. I know my standard deviation is 40. What I don't know is I don't know the mean for this particular sample. So what I'm going to now do is insert like a little computation for X-bar. So I'm going to go into math. Sorry. I actually need to go back. Sorry. So stat, go over to test, option 7. And I'm going to go down to statistics. So do second. Stat, it takes me into the list feature, but I want to go over to math because I'm going to find the mean of a list. That's why it's located here. So then I'm going to select option 3, and then I'm going to do list 1. So it sort of computes this on the fly, if you will, like right there in the middle. Okay, so that's the mean. It gave it to me right there. And then I'm going to put 99 here because that's what we're supposed to construct. And then I'm going to press calculate, and there's my interval. So the goal is to capture the true population parameter, which is a mean of 100. Mu is 100 there. Now, I want to do it again, but I want to write down this interval. So you're going to write down the interval you get. Yours will not match mine, but you're going to write that down. So let's go through the process again. The first thing I'm going to do is I'm just going to press enter, and it's going to actually create a new sample for me. It's kind of neat. So it does it for you. So just press enter. Now I need to go back in and do stat, go over to test, option 7, and the only thing I change now is every time I have to recompute the new mean because I got a new sample. So I'm going to do second stat, go over to math, it's option 3, and I want the mean of my new list 1, and it won't be the same thing. Last time it was about 100, this time it's lower. And then just calculate. And you write this down. And again, it did capture my 99% confidence level. Or the 99% confidence level did capture the true population parameter. So press enter again, and you get a new sample of size 4. And then you go back and do the test. So stat, test, option 7. And the only thing I have to change is I have to input the new mean. So I want to do option 3. And I'm going to do list 1 for the new mean. So there we go, and I get a new confidence interval, and it also captured the mean mu, which is 100. So you're going to repeat this many times, so just pause the video and go ahead and do this. I think I said 10 times, so do it at least 10 times. And you're going to write all those values down right here in this section here. And we will discuss some of those tomorrow. Okay, now going on to the next little section. Okay, so the method in step 1, what we did here, it works if and only if we know the population standard deviation sigma. Okay, so it works well if we know the population standard deviation sigma. So that's the notation there. That's rarely the case in the real world. So what happens if we use the sample standard deviation S in place of sigma when we're calculating a confidence interval for the population mean? So let's just kind of review what we're going to do. We're going to do the same thing again, but now we're not going to use 40 for our standard deviation. We're going to actually compute that every single time we get a new sample. So it's going to change every single time. So I want to kind of remind you what we're doing here. So now our interval is still going to be what we call a z-interval, but we're going to use X bar plus and minus, and it's going to be our z star again. And then now we're going to use s divided by the square root of n. So this is the main thing that has changed from the first process we did. So x bar plus and minus, and then we still have our critical value of 2.576. S we'll have to get every single time, and then we'll have the square root of 4 for the denominator there. So every interval is going to be computed that way. But now we have two things we have to compute for the new sample that we get. So we're going to repeat this. So we're going to do pretty much the same thing we just did. I'll show you how it is modified. So I'm going to create a new sample, just press enter, and there's my new sample. So now I'm going to go to Stat Test, option 7 again. But now instead of doing 40 every single time, I'm going to actually do, okay, so now instead of using the 40 that we know to be the population standard deviation, which is rare, you really would not know that information because you're creating a sample so that you can estimate the true population mean. So you're not going to know sigma. So we're trying to explore what happens when we construct the interval the same way as if we knew sigma, but we're going to have to use an estimate, which is going to be S for sigma. So what I'm going to do now is I'm going to go back into math, and I'm going to do option 7, and it will be on list 1. So now this changes every single time as well. But I also have to do X bar, so second list, math, and then go down to the mean, and I want the mean of list 1. And I'm still going to construct a 99% confidence interval. Okay, so there's my interval. That was the mean that time. So you're going to do this 10 times. But again, you're going to actually just press enter to repeat getting a new sample. So that's very simple. And then you're going to go Stat Test, option 7, and then you just need to go and basically grab the standard deviation of list 1. It's a different value now, so it went down some. Last time it was 30. And then I'm going to also grab the mean of list 1. So I'm going to get a different interval this time. Okay, so it captured 100 again. So you're going to do this and kind of observe how often is it capturing versus how often it's not capturing the true population mean. So you're going to fill in this next little section with your 10 intervals. And we're going to talk about that some more tomorrow. Okay, so how do the two methods compare? Did one method do a better job of capturing the true mean? It appears that the intervals, and this is actually what is happening, it appears that the intervals are more narrow when using S versus sigma. In other words, the distribution, the Z distribution, I should say, does not appear to match the sampling distribution of X bar when we do not know sigma. So what's happening here, I'll kind of summarize this. You're going to read this in the book as well. When you have your Z distribution, you know, it's a normal curve, basically. It actually is normal. The T distribution is not normal. It's not a normal curve, but it appears very symmetrical, has a lot of the same features. So let me sketch this in. I'll do my best to kind of simulate what's happening here. I'm not doing the best job drawing it. But essentially what happens is you end up with more area in the tails, meaning that you end up with less area in the middle, meaning that often your intervals do not capture the true population parameter to the confidence level that you would like. So you can't use the normal distribution. You have to switch over to the T distribution. So we're going to explore Rossmann-Chance tomorrow in class to kind of review some of this. But be sure to take notes on the back for the pages that you're supposed to read tonight.